All right, Bernardo. So we are going to do number 7 now. All right. Okay. So here we go. Um, oops, I forgot the opening part. Consider the function. Okay, so I'm going to group it, make it smaller. All right, here we go. Consider the function f of x equals a to the x. Great. A is a real number, so that's any number on the number line. X is greater than 0, A is greater than 1. Great. The graph contains this point, show that A equals 8. All right, so sweet. All we have to do is all we have to do is plug in and solve. So f of x equals a to the x power. We have to show that a equals 8, right? Well, we can do that because we have a coordinate, right? We have a value for x, 2/3, and f of x, 4. So I'll replace f of x with 4 equals a to the 2/3 power. Right now, I'm going to assume no calculators involved, so we can do this, right? So I'm going to raise both sides to get rid of the 2/3. I'm going to raise both sides to the 3/2 power, the reciprocal of 2/3. And that's because when you raise a power to a power, you multiply them, right? So that's 2/3 times 3/2, which is a to the 6/6, which is a to the first, which is a. I will never write that again. I was just showing you how that works. And then 4 to the 3/2 power becomes the cube root of 4. No, the square root. What's the matter with me? The square root, because 2's in the denominator, of 4 cubed. Now that cube can go inside or outside. 4 cubed is not that big of a number, so I'm going to leave it inside. All right, so a is equal to the square root. 4 cubed is 64, and a is equal to 8. So we've shown it. Now, 4 to the 3/2, just to review, is equal to the square root of 4 cubed, because a to the m over n power is equal to the nth root. And since it's a 2, we don't put the 2 there because it's understood it's a square root, right, of, a to the m power. Okay, so that's where that came from. Okay, so we got that going for us. Give me some real estate here. Okay, and let's try B. Bonk. Write down an expression for the inverse. All right, so we have f of x equals 8 to the x, right? And oops, equals. And to do the inverse, I'm going to write it as 8 equals 8 to the x, or y equals 8 to the x, sorry. And to do the inverse, remember, at f negative 1 of x, that's where we switch the x and the y, and we solve for y, okay? Now, I'm going to take the logarithm of each side, but I'm going to do a base of 8. Log base 8 of x equals log base 8 of 8 to the y power. And the reason I'm doing that because I can choose any base I want. If the base 8 is this guy here is the same as the argument 8, right? If these guys are the same, then the logarithm is equal to whatever the exponent is. So that means y equals log base 8 of x. So that's our inverse. F negative 1 of x is equal to log base 8. Oops. Is equal to log base 8 of x. Sweet. Boom. We got that all going for us. Make it smaller. And now let's try C. Okay, so C, what's going on here? Find the value f negative 1 of 32. Great. So the inverse, or square root 32, right? F negative 1 of 32. Well, we know that f negative 1 of x is equal to log base 8 of x, right? Log base 8 of x. So I just plug this in. So f negative 1 of root 32 is equal to log base 8 of root 32. Okay, so let's see if we're going to be able to do this by hand. I think we can. 32 to the 1 half, that would be 16. I can do 8 times 4. Oh yeah, I can. Um, log base 8 of 32. I'm thinking, how do I want to do this? Give me 1 second. Control log 8. Okay. Well, let's see. Find the value. Well, we're going to do some logarithm stuff. I think. Let's try this. So this becomes log base 8 of 32 to the 1 half power. So that's just writing the square root of the square root raised to the square root of anything is equal to the anything to the 1 half power because of this rule here. Okay, so now there is a logarithm. Let me get my rule of logs here just so you can see where they're coming from. They are all right here. Whoop. Trying to get this to turn out nice for us. Okay, so there's our log rules. I'm going to slap that over here for us to use. Okay, the rule I'm going to use here is I'm going to move this, because it's an exponent, 1 half, I'm going to move it in front of the log. So this becomes 1 half log 8 of, log base 8, 1 half log base 8 of 32. And that 8 is a little high. It's a base. It should be going down here to have the proper notation. Okay, so the reason I thought I should do that is I can now rewrite this as 1 half parentheses log base 8 of 8 plus log base 8 of 4. Hoping this is going to turn out nice. I'm thinking. Ignore me for a second. Yeah, here's what we're going to do. Okay, I take it back. And it's hard to see this, Bernardo. This could have worked, but the 8 to the fourth power is going to be a problem. I'm not going to be able to simplify it. However, if I did log 64 minus log 2. The reason I can do that is this formula right here. Um, and that will then turn to log base 8 of 64 over 2. Okay, which equals log base 8 of 32. So they're equivalent, right? But writing it like this, I can evaluate this, right? And now this is not part of it. I'm just showing how 60, I can write 64 minus log base 2 as 64 over 2 because it's equal to log base 8 of 32. And now this is if it's by hand, which I think it could be. You could do it on your calculator, but you're going to get a messy decimal. Not messy, but I'll show you that in just a second. But then you could change it to a fraction. Okay, but just in case, I'm showing you how to do it by hand. All right, so then this would turn into 1/2. Um, so now I'm doing this one, right? This was just showing you why it's equal. So I'm going to get rid of this arrow as not to confuse you and show you what the real arrow is. It goes here. Okay. And it's in red. I want it in blue. Whatever. So log base 8 of 64 is actually log base 8 of 8 squared, right? And because of the rule I showed you here, that's going to be equal to 2. That's fantastic news. Minus log base 8 of 2. Okay. Now, let me do something here. This is something we have to, I'm trying to get the base the same as the argument. Now it's equal to 2, but do you agree that the cube root of 8 is equal to 2? And the answer there is yes, it sure is. Okay, and because of that, I now have 1/2 times 2, because log base 8 of 8 of 2 is 2, minus log base 8 of 8 to the 1/3 power. So that's the whole reason I did this, is I could get 8, 8 here and 8, 8 here, and then it's equal to the exponent. So then that's 1/2 times 2 minus 1/3. Okay, which is, and again, this is all to show you how to do it by hand. 1/2 times 6 over 3 minus 1 over 3, which is 1/2 of 5/3 times 5/3, which is equal to 5/6. Holy smokes. Now, if you can use a calculator, let's see. Okay, I'm going to do log. Where's my log? Control log. Nope, that's wrong. There it is, 10 to the x. Control log base 8 of square root of 32. So control square root 32. And I get that nasty decimal. Now, you either recognize that as being 5/6, or you go menu to change it to a fraction now. Menu, number, approximate to fraction, and watch what happens. Ooh, that's nasty. Since there's so many zeros, you could take 20 over 24 and set it equal to 1. I'm surprised that it didn't come to 5/6. But you can ignore this 1 at the end, right? It's just the calculator couldn't handle it. I'm surprised here. Let me just show you. 5 divided by 6. Now I'm going to write that as a decimal. Gosh darn it. Menu, number, convert to decimal. And you'll see it's 0.833333333, like that. Okay. All right. So on a calculator, you could do it that way. Okay. So let's make that all smaller to do part D. Trying to just be able to see the problem, Bernardo. Hang in there. All right. Ooh, what happened? Did I miss something? How did I miss something? Like the equals. Oh, that's why. I must have erased something there. Okay. All right. So I don't know where that equal sign came from. All right. I don't care. C. All right. D. Show that 27 P, Q, and 125 are 4 consecutive terms of a geometric sequence. All right. So we had to consider this. Consider the arithmetic sequence. Log base 8 of 27, log base 8 of P, log base 8 of Q, log base 8 of where P is greater than 1 and Q is greater than 1. Show that 27, P, Q, and 125 are 4 consecutive terms in a geometric sequence. Okay, 4 marks, so we got a little bit of work to do. I think I'm going to move over to the next page to give us some more room. Okay. Make this a little smaller. Okay. All right. So now we've got D. 27, P, Q, and 125 of consecutive terms in a geometric. So P and Q are here. Now they say this is arithmetic. All right, fine. Log base 8 of 27, log base 8 of P, log base 8 of Q, and log base 8 of 125. So we got to solve for these. So if this is arithmetic, first of all, this is use of 1, use of 2, use of 3, and use of 4. We know that the common difference is log base 8 of P minus log base 8 of 27, right? Term minus previous term. We also know that log base 8 of Q minus log base 8 of P is the common difference. So these are all equal, right? Each of these is the same common difference. All of them are equal. And then lastly, we know that log base 8 of 125 minus log base 8 of Q is equal to the common difference. So they're all equal to each other. That's the key here. Okay, so now I'm going to rewrite these to make it a little easier using this rule here, difference of logs, as log base 8 of P over 27. And I'm just going to make them equal right now. Doing the same thing here is log base 8 of P over Q. And also log base 8 of P over Q is equal to log base 8 of Q over 125. Or 125 over Q. 125 over Q, sorry. This should be Q over P. Sorry, I don't know what's the matter with me. It's this one over this one. Let me make sure. Yeah, I don't know why I wrote that wrong. Sorry. Q over P. And then Q over 125. Keep writing it as a 9, sorry. All right, so log base 8 of this is equal to log base 8 of this. So that means P over 27 is equal to Q over P. And that P squared is equal to 27Q. This is why it's worth 4 marks. And same thing here, I know that P over Q is equal to Q over 125, right? So same reason again. So cross multiply again, Q squared equals 125 times P. So we're going to do some substitution here so I can get one variable. I'm going to divide by 27, so P squared over 27 is equal to Q, which I can then plug in to here. I can replace this Q with P squared over 27. So P squared over 27 squared is going to equal 125P, right? So P to the 4th over 27 squared. So now I'm convinced the calculator is allowed. They're not going to make you square 27. 729. So P to the 4th over 729. 729, Dave. 729, right? Yep, 27 squared is 729 equals 125P. And so we're on a mission to solve for P, right? So we're going to multiply both sides by 729. So 125 times 725 is 91125. So P to the 4th equals 91125P. Since they both involve P, we're going to bring it over. Minus 91125P equals 0. I'm going to factor out a P. I get P cubed minus 91125 equals 0, which allows me to set them both equal to 0. P equals 0. P cubed minus 91125 equals 0. And I'm going to scroll back up to see if there's restrictions, right? Both P and Q are greater than 1, so that means P can't be 0. So let's keep going. Equals 91125. I take the cube root of that. Whoop. 91125. Let's do that. Cube root. Control. Root. Cube root. Please be a perfect cube. I have a feeling it is. 45. Holy smokes. So P equals 45, Bernardo. Woo! Right? 4 marks. Now, I also know that Q equals P squared divided by 27. Well, I just found out that P is 45. So Q equals 45 squared over 27. All right, back here. I love me the fraction, as you know. I forget already. 45 squared over 27. 45 squared over 27. 75. All right. So Q equals 75. So we have our freaking answers there. Woo! 75. Boom. Boom. I think we're going to have to go to the next page to finish this. Find the value of P and Q. Wait a second. Oh, we have to show they're in a geometric sequence. Well, see, this is weird because in order to show that they're a geometric sequence, we have to find P and Q first, Bernardo. So I've already finished E, right? To show that it's a geometric sequence, we first had to find P and Q. So they should have had these questions reversed, I think. So that was a 5 marker. So Okay, so let's just think about this now. I'll do this in red to differentiate it. 7D, if this is a geometric sequence, I got 27, I've got P, I've got Q, and I have got 125, right? So if it's indeed a geometric sequence, U3, U4, then the ratio of the consecutive terms have to be the same. That's what has to have the same common ratio. So that means that P over 27 has to equal Q over P has to equal 125 over Q. So now let's plug in. P is 45, so 45 over 27. Q over P is 75 over 45. And then 125 over 75. Let's see what they all equal, right? So both of these are divisible by 9, so that would be 5 over 3. Both of these are divisible by what? So I'm going to divide by 3 first. So that's 25 over 15. Then I'm going to divide by 5, which is 5 over 3. So boom, boom. Both of these are divisible by 25. 125 divided by 5 is 5. 75 divided by 5 is 3. Boom. We did it. Holy smokes. All right. I'll make another video in a sec.